Welcome to the deep dive. Today, we're diving into, ways to make learning complex subjects like physics a little easier.
Okay.
And we're doing that by exploring the work of Lu Kang Wei. He's a researcher right here in Singapore, and he's really passionate about something called open educational resources.
Oh, yeah. OER.
Exactly, OER. Basically, it's all about making really great learning materials available to, well, everyone for free.
It's a great concept.
Yeah, it is. So we've got a bunch of his publications to look at, plus we're taking a peek at his project website. So
Sounds exciting.
let's jump right in.
What I think is so fascinating about Wei's work is, well, he's not just giving us information, he's actually creating these tools tools that change how we learn.
I'm intrigued. What kind of tools?
So imagine you're trying to learn about something like radioactive decay.
Okay.
You could read about it, sure.
In a textbook, yeah.
Right. But what if you could actually see it? Like, what if you could experiment with it? Well, that's what Wei is doing with, it's called Easy Java JavaScript Simulations, or EJS.
EJS. So like computer simulation.
Exactly.
I'm guessing that's where the JavaScript comes in.
Exactly. He's using EJS to create interactive simulations for all kinds of physics concepts, like resonance, electromagnetic induction, projectile motion, really, you name it.
Oh, wow. So instead of just reading about, say, how a projectile moves through the air, you can actually launch like a virtual ball and see what happens when you change the angle or how much force you use.
Yeah.
That's amazing.
It is. And it's way more fun than just staring at a diagram in a textbook.
Right.
But it's not just about making physics, more fun. It's really about making it easier to understand.
Yeah, I get that. I mean, I remember struggling with physics back in school. It all felt so theoretical, so disconnected from, well, real life.
Right.
Like, how does this apply to me?
And that's where these simulations can be really powerful. They can bridge that gap between theory and reality.
Oh.
You're not just memorizing formulas, you're seeing how they actually work.
Oh, in the virtual world.
Yeah. You're learning by doing, by experimenting.
Makes sense.
Exactly. And that kind of active learning is much more effective than passive learning. It helps you grasp those aha moments, those moments where things just click.
Yeah, I love those.
And that deeper understanding, it sticks with you.
I bet. And I'm guessing it makes physics a lot less intimidating, especially for, people who might feel overwhelmed by the subject.
Absolutely. When you can actually see these concepts, it takes away some of that mystery. It makes it more approachable.
Right.
And it's not just for, high school physics either. Wei's designed simulations for all levels, from primary school up to junior college.
Wow, that's quite a range. But you mentioned that he's not just focusing on these abstract concepts.
Right.
What are some of the other examples of his simulations?
Well, he's also got simulations for more practical things, like using tools for measurement.
Okay.
Like a vernier caliper or a micrometer.
Huh.
Okay.
There's even a vernier caliper app on his site.
A virtual vernier caliper. Wow, that's clever. I see how that would be helpful for students who are just learning how to use these tools, like getting hands-on experience, but, without needing the actual tools.
Right, exactly.
Very good.
And it lets them make mistakes and learn, but in a safe space.
I like that.
Yeah.
So EJS sounds like a pretty versatile tool.
Yeah.
But let's back up for a sec. What is it about EJS that makes it so good for creating these simulations? Is the programming language itself?
Well, partly, yeah. Both Java and JavaScript are really common and relatively easy to learn.
Yeah.
But I think the real strength of EJS is in its, its simplicity and flexibility.
Okay.
It lets educators, even those without a ton of coding experience, create custom simulations that fit their needs.
So it's not just about using pre-made simulations, it's about empowering educators to make their own.
Exactly.
That's fantastic.
It is. And that's something that really excites me about Wei's work.
He's not just developing these awesome tools, he's sharing them with everyone for free.
Okay, so now we're back to OER, right? Open Educational Resources.
Yeah.
This seems like a key part of his whole approach.
It is. He's really big on making educational resources open and accessible to everyone. So all his simulations, his research, all of his materials, they're all freely available online for anyone to use, adapt, share, whatever they want.
That's incredible. Think about how many students and teachers around the world could benefit from this.
It's amazing.
It really is.
It's a game changer.
It really is. And it gets to the heart of what OER is all about, right? Breaking down those barriers to knowledge.
Yeah.
Making quality education accessible to everyone, no matter what their background is or what resources they have.
Exactly. It's about democratizing knowledge.
It is. You know me, though. I always want to know more.
Of course.
So EJS, clearly a huge part of his work.
It is.
Are there any other projects that he's involved in that kind of tie into this idea of making physics more, um, engaging and accessible?
Oh, tons. And this is where it gets even more interesting. He's also done some really cool work with a video analysis software called Tracker. So Tracker basically lets students analyze real-world videos, like objects in free fall,
Okay.
and it helps them really get a grasp on concepts like gravity and motion.
So they're not just working with simulations, they're actually analyzing real physics.
Right.
I love that. That's a whole other level of engagement.
And it reinforces this idea that physics isn't just this abstract thing you read in a textbook.
Right.
It's happening all around us.
All the time, yeah.
Yeah.
I bet that sparks some curiosity, too.
Oh, absolutely.
To ask more questions, dig a little deeper.
Yeah, and that's where inquiry-based learning comes in,
Right.
which is something Alate Hiriar really emphasizes. Instead of just, passively absorbing information, students are encouraged to ask their own questions, design experiments,
Wow.
really explore the why behind things.
I love that approach, that kind of thinking, questioning, exploring. That's valuable in any field, really.
Totally. It's about fostering critical thinking, problem solving, a real thirst for knowledge.
Yeah.
And that's something we can all benefit from.
Yeah, absolutely. Okay, so we've got EJS for these interactive simulations, Tracker for video analysis.
Yeah.
Anything else in Wee's toolbox that caught your eye?
Well, there's another project that I find really interesting, his work with robotics in education.
Robotics. Okay, that sounds really cool.
It is. We sees robotics as this amazing platform for teaching so many skills, everything from programming to problem solving to, of course, those physics principles.
So it's not just about building robots for fun.
Oh.
It's about using them to learn.
Exactly. It's about hands-on experience, letting them design, build, program robots, which can be really engaging.
Yeah. It reminds me of those those old lecture sets.
Yeah.
But, taken to a whole new level.
Totally. It's like taking those building blocks and then making something that can move and interact with the world.
Exactly. And I bet there's a whole world of coding and problem solving that goes into that.
Oh, yeah. Students have to figure out how to make the robot move, how to make it respond to sensors, how to get it to actually do something.
So it's really multidisciplinary.
Oh, for sure.
It's science, it's technology, it's engineering. I imagine even a bit of art in there, designing these robots.
Absolutely. And it's all tied into this idea of, making learning more hands-on, more interactive, more relevant.
For real world, yeah.
Exactly.
And, of course, it all goes back to open access.
Right.
All of these tools and resources that Wee's developing, they're freely available for anyone to use.
That's right. It's all part of his commitment to OER. He truly believes that knowledge should be shared.
Which is why we're so excited to be, diving into his work today.
Yeah.
It's not just about looking at one researcher's projects. It's about, this movement toward open education.
Exactly.
And hopefully inspiring our listeners to explore it more.
For sure.
So we've covered a lot. EJS, Tracker, robotics, all really innovative approaches to learning. But before we wrap up, I want to bring it back to our listeners.
Okay.
What does all this mean for them? Why should they care about OER and the work that Lu-Kang Wee is doing?
That's a great question. And I think the answer is, well, it's multifaceted.
Yep.
First of all, OER gives people access to great learning materials, things that might be too expensive otherwise.
Right.
It levels the playing field, letting anyone with an internet connection get to the same resources as students in, top-tier schools.
It's about making sure everyone has a chance to learn and grow no matter, where they come from or their financial situation.
Exactly. And beyond access, OER also encourages a more collaborative and innovative approach to education.
Interesting.
It lets educators share their best practices, change existing materials, and create something really unique for their students.
It's like this giant global brainstorming session
Yeah.
with educators from all over the world
Yeah.
just sharing ideas and, pushing the limits of what's possible.
Exactly. And that energy can be really powerful. It can lead to new ways of teaching, better learning experiences, and ultimately a deeper understanding of the world.
And speaking of deeper understanding, let's go back to those interactive simulations for a sec.
Okay.
I'm curious, what are some of the benefits you see in using simulations like the ones Wee has made?
Well, one of the biggest benefits is that simulations allow people to visualize these really complex concepts that are, really hard to get just from traditional methods.
Okay.
Take electromagnetic induction.
Yep.
It's a pretty abstract idea.
It is.
But with a simulation, you can actually see how a changing magnetic field creates an electric current.
So you're bringing these invisible forces to life.
Exactly. And it's not just about visuals.
Okay.
Simulations also have a level of interaction that you just can't get from, like, textbooks or lectures.
Yeah.
Learners can experiment with different things, see how those changes affect the outcome, and get a feel for how things actually work.
It's like giving them control of the experiment.
Exactly. And that leads to deeper learning. When you're actively involved, you're much more likely to remember it, to understand it, to be able to apply it.
It's not just about memorizing. It's about really understanding.
Right. And that's what makes simulations so powerful. They can really change how we learn, make it more engaging, more effective, and ultimately, more meaningful.
Okay. So we've talked about access, collaboration, engagement, and deeper understanding.
Yeah.
All pretty great reasons to care about OER and what WE's doing.
Right.
But I have to ask, is there a downside to all this? Are there any, challenges or drawbacks to using OER in simulations?
That's a really good question, and one we should definitely consider. OER and simulations aren't, a perfect solution.
Right.
They have limitations, and it's important to be aware of those.
So what are some of those limitations?
Well, one of the biggest challenges is making sure OER materials are high quality.
Yeah.
Just because something's free and online doesn't automatically mean it's accurate, well-designed, or good for teaching.
That's a good point. There's so much information out there, it can be hard to find the really valuable stuff.
Exactly. And that's where being able to evaluate things critically becomes important. Educators and students need to be able to assess the quality of OER materials just like they would with any other educational resource.
So it's not just about finding free stuff, it's about finding good quality free stuff.
Exactly. Another challenge is technical infrastructure.
Okay.
Simulations, especially those that need complex software or fast internet, might not be accessible to everyone.
So the digital divide is still a factor.
Yeah, it's important to keep that in mind and make sure everyone has equal access.
That's great.
And lastly, we have to remember that simulations are just one tool.
Right.
They can't replace good teaching, hands-on experiments, real-world experiences.
You just complement those things.
Exactly. And I think that's the key takeaway here.
Okay.
OER and simulations can revolutionize education, but they're not magic. They need to be implemented thoughtfully, evaluated carefully, and we need to make sure that everyone has a chance to benefit from them.
That's a great point. And it's a perfect way to lead into our final question for our listeners today.
Okay.
We've spent this deep dive focused on Liu Kangwee's work. But his efforts are just one example of all the incredible things happening in the world of OER. So as we wrap up, here's something to think about.
Okay.
Imagine these interactive learning tools, like the simulations WE's making, but for every subject.
Wow.
Not just physics. How would that change the way we learn?
That's a really interesting question. It really makes you think about the potential here. Think about history, for example.
Yeah.
What if instead of just reading about historical events, you could actually experience them through a simulation?
Right.
Imagine walking through ancient Rome.
Whoa.
Or being part of a debate in the Roman Senate.
That would be incredible. It would make history so much more, alive.
Exactly. It would be way more engaging, for sure. Yeah. But it wouldn't just be about making it fun.
Right.
These simulations could help people understand historical events on a much deeper level. See things from different perspectives.
It's like stepping into a time machine.
Yeah.
Not just to see the past, but to really get it.
And that kind of immersive experience could work for anything.
Oh, yeah. Imagine exploring the human body in biology.
Yeah, or building a city in, a civics class.
Right. Or even composing music with a virtual orchestra.
The possibilities are huge.
They really are. It makes you wonder, what can our listeners do to, help make this happen?
Well, I think the first thing is to just be aware of what OER can do.
Okay.
And to advocate for it, Talk to teachers, schools, policymakers.
Right.
Spread the word about all these amazing free resources. Encourage people to use them.
Yeah, and for those who are, really ambitious.
Yeah.
Why not try creating your own OER materials?
Exactly. There are so many tools and resources online to help you get started. Who knows? You might make the next big educational simulation.
You might. Well, speaking of simulations, we can't finish without mentioning some of the ones WE's made.
Oh, for sure.
His website is full of them.
It really is, like those simulations for speed, distance, and time with the race car,
Right.
or understanding resonance.
Yeah, and those fun interactive games, too, like Help Simi Eat the Correct Fish. What was it?
Transit Planner Simulator, and let's avoid sea pollution.
Right. Those are great. They're perfect for learning and having fun at the same time.
They are.
We'll make sure to include links to all of those in the show notes so everyone can check them out.
Perfect.
And remember, this is just a tiny part of the world of OER.
Yeah, there's so much more out there to discover.
So keep exploring, keep learning, keep sharing.
Couldn't say it better myself.
And that's it for our deep dive into the world of open educational resources.
Thanks for having me.
It was great having you. A huge thank you to Lu Kang Wee for his work and for, really inspiring us to think differently about learning.
Definitely. He's a real leader in this space.
Until next time, keep those minds curious and keep diving deep.